All right, we're going to be talking about absolute value equations today, section 3.05. So let's first review what an absolute value is. So if you recall, the absolute value of a number measures its distance from zero. So when we see the absolute value of 5, that means how far away is 5 from 0, and we think about it as on the number line. So 5 is to the right, 1, 2, 3, 4, 5. All right, and it is a distance of 5 away, 5 units. Okay, so that is what the absolute value of 5 is equal to. It's 5. All right, same kind of question, but for -6. We go to the left 6 for -6. But how far is that from 0? Is a +6 units. We never give a negative answer to this. It's always positive, or more accurately, non-negative, because if we ask ourselves, what's the absolute value of 0? How far away is 0 from 0? Well, 0 is right on 0, so it's a distance of 0 from itself. Okay, so absolute value always gives a non-negative result, or always positive for the most part, except for this special case of the absolute value of 0. All right, so we're going to be looking at a more advanced question now, where we've got a variable. So if the absolute value of x, so some number x, is equal to 3, then what is the value of x? Well, you got to think, well, what could this number be inside here for it to equal +3? Well, that's asking, hey, what number has a distance of 3 from 0? So what number is 3 away from 0? And actually, there's going to be, the weird thing about it is there are two answers, because we can have the positive direction to the right, 1, 2, 3. That number, which is 3, that's 3 away from 0. But also, we can go 1, 2, 3 to the left, that's -3. That is the same distance, it's just to the left. So there's actually two answers here. X is equal to +3 and -3. Sometimes you'll see that written as ±3 when it's the same answer. You could also write it as, you could just list it out, x equals -3, 3. Either of those forms of the answer would be acceptable. All right. Okay. Looking at a even more advanced question. Okay, so again, we have the absolute value. It's equal to 7, so that's saying that the distance of the stuff inside the absolute value is 7 away from 0. Now, it's a little more complicated in that it's x plus 2. But this is where we can use the property of the absolute value to come in handy here, because we know that every absolute value has two different directions that it can go to get 7 away. It can go to the right, which would be a +7. It can go to the left, which would be a -7. So we have a negative version. So this is the negative version, which would be x plus 2. That could equal -7, going to the left 7. We also have a positive version, where it's going to the right, so x plus 2 would equal +7. And now we can solve each of those separately, right? Because we have not technically solved for x on either of those yet. Subtracting 2 from each side, that'll cancel, and then we'll be left with x equals, that'll be -9 in the left direction, the negative direction. Okay. Now, to solve on the green one, the positive direction, we subtract 2 from each side. The 2's cancel. And that is x equals +5. Okay, so we've got x equals -9 and x equals +5. So it's not always going to be like that plus or minus type of answer. It could be, but not necessarily. So it would be nice to maybe write all that in one answer, maybe off to the side. Another way you could see this written as is in this answer set. Since we have more than one answer, -9, 5 in an answer set, solution set. Okay. Okay, let's take a look at another one. All right, so in one like this, where there's something on the outside of the absolute value, in this case it's the -4, we need to get rid of that first before we can do that split move, because we will be doing that split move, but we need to cancel that -4 out first, because we need that absolute value part to be isolated. We want everything inside these red bars, only that on the one side of the equal sign. Right now we also have this -4, so the way we get rid of a -4 is maybe what you'd expect, is to add 4. And so now we'd have the absolute value of 2x plus 3, but now it's equal to 9, and it's isolated. The absolute value, there's nothing else on the left side of the equal sign. Isolated means by itself. So now we can take this and say, hey, okay, this is going to split. Let's see, I don't have a ton of space, but I'll do the negative version right under here. So if we went to the left, it'd be 2x plus 3 equals -9. And I'll do the right up here. This is the positive direction. So that'll be 2x plus 3 equals +9, going to the right. And we solve each of these. So I'll do this green one with where I've got more space. Remember, we always take care of the subtraction or addition first in a two-step equation. That'll be 6. Then we take care of the multiplication, or in this case, we divide second. So this is a nice review of solving a two-step equation. So x equals 3. Now on this other side, same moves. That's this thing. Same moves. So that means subtract 3 first. And that'll be, let's kind of run out of space here. So 2x equals, what is that, -12, -9 minus 3. Then divide by 2. Divide by 2 on both sides. And we've got x equals -6. All right, so our solution set is -6 and +3. So that one, just a little review there. We had to get rid of that -4, so that we could then do the split move. You can't do the split move until you've isolated the absolute value. That's very important to remember. So get rid of anything that's on the outside of the absolute value bars first. So here's another example. We've got the 3 on the outside of the absolute value. Now there's no symbol. If you recall, that means multiplication, right? So that's 3 times. So we will need to undo that before we do any positive negative move, and we will divide by 3 on both sides, right? Because that undoes multiplication. So we still have the absolute value, but it's isolated. There's nothing else on the outside of it, and it's equal to 8. Okay, so let's see, maybe I'll use my space a little different. So the negative version will be -4x. Going to the left would be -8. And the positive version, it still is -4x. That part doesn't change, but it's then +8. So it's the constant number away from the absolute value. That's the number that switches positive negative. And now in some instances, like in this case, actually it wouldn't make a difference. It would not make a difference. But You can't rely on that every time, but here, okay, I would divide by -4, right, because that means -4 times x. Those cancel, and -8 divided by -4 is +2. Do a similar thing on the other side, divide by -4, that cancels there, and x is equal to -2 on that case. So this is one of those situations where we do have the same number, but it's a positive negative. So you could say that the solution, you could write it like this, plus or minus 2. Or again, you could list it -2, comma, +2. Either way is fine, but just showing you a new notation. Okay. Couple more examples here, some special cases to finish off here. Okay, now one like this, we've got a little bit more to get rid of on the outside. So we have the +6 and the 2 being multiplied on the outside, but both have to go before we do any kind of splitting. And just like solving a two-step equation, you got to get rid of the addition before you get rid of the multiplication. So we're going to start by subtracting 6 from both sides. And actually, it cancels on both sides. So it's important to remember that that's going to give us 0 on the right side. We do have to write the 0 there. Okay, and then technically we have to then divide by 2 to get rid of this multiplication of 2. Divide by 2. And that's pretty easy because 0 divided by 2 is just 0. But the main goal was we got the absolute value isolated. Now, this is a situation where it's saying that the distance that x plus 5 is from 0 is 0, meaning we're landed right on 0. We want the distance to be 0 away. So you could try to keep doing the positive direction and the negative direction, but you can't. 0 has no sign. It's neither positive nor negative, so you can't do a negative version, a -0 and a +0. That doesn't exist. So in this case, it's just one equation. So there is no splitting because it's equal to 0. And if you did split it, you'd get the same answer both times. But we just have x plus 5 equals 0 because the distance is nothing. So when we subtract 5, we just get 0 minus 5, which is -5. And that's it. Just one single answer. So it's possible, if the absolute value is equal to 0, meaning that distance is nothing, then in that case you do get just one answer. So it is possible to just get one answer for these. And one more problem, this is another special case. Notice that we have that +8 on the outside of the absolute value. So we will have to cancel that out by subtracting 8 from each side. And then you've got the absolute value of 5x minus 9. That's now equal to -6. And now here you got to be careful. If you get a problem like this, this is a special case because it's saying that the absolute value is equal to a negative answer. And we know that that's not possible, right? Not possible because absolute values always give us a positive answer or a non-negative. It can be 0 like we saw in that last problem, but it can't be negative. So if you get a situation like this where you have an absolute value isolated and it's equal to some negative number, then that's actually no solution. So that is a special situation. All right. And that concludes our lesson on absolute value equations.